right, so yesterday we got started talking about the movement of things across the cell membrane. We had our passive movement, meaning it does not require energy. Tell me what the passive movement of molecules across the membrane was referred to as. It is diffusion. Now, diffusion, remember, it is moving from highest to lowest concentration. Tell me what that's called when we're looking at the comparison highest to lowest concentration. The concentration what? Gradient. Yes. The greater the difference, the faster it's going to go. I like to think of it like a slide. If there's a big difference between the highest and the lowest, very quick movement. If there's not a lot of difference, then it's going to be a very slow movement. Now, what was the passive movement called if I have a helper protein? Facilitated diffusion. To facilitate means to help, helping you out. I'm facilitating you learning this material, hopefully. Hopefully. All right, what was the movement of water? This is osmosis. Now remember, with osmosis, molecules can't move. Diffusion, we're moving the molecules because we want everything even Steven, right? If I have a higher concentration, I want to bring it even Steven. Diffusion, facilitated diffusion, is the movement of molecules. Osmosis, the molecules are not allowed to move. It's the water that will move and dilute the molecules so that we get that even Stevenness in the concentration. And then, did we get to filtration? We did not. All right, so we are going to discuss today the fourth and final passive Okay, I think we did talk about this though, right? Isotonic, hypertonic, hypotonic. I really need to fix that.
Yes,
because you can't be more concentrated on the outside than on the outside. That doesn't work, does it? So when we're saying hyper, hypo, we are specifically referring to the outside of the cell. So hyper, the concentration is greater on the outside than the inside. Hypo, the concentration is less on the outside than the inside. And this will promote the movement of fluids. So if I have a cell, don't forget you guys, you are allowed to draw on this if you want to. I have a cell, the pressure is greater on the outside than the inside, and I want this to be even Steven. How is it gonna move? So I'm going to be moving stuff out. This is going to be really important when you get to what? Pharmacology, clinical pathology. When we're trying to promote the movement of things either in or out of cells. The difference between our pressures in our blood and our tissues is known as oncotic. So you have blood pressure, which is obviously the pressure of blood. Every time your heart beats, it splooshes out some blood, and the pressure on the inside of your blood vessels equals your blood pressure. But the difference between the pressure in the blood and the pressure of the fluid in the tissue is known as oncotic pressure. And the higher this pressure, the more we're going to be moving stuff back and forth, just basically kind of pushing by force, if you think about it like that. I'm going to minimize you guys. So it's just terminology, a little bit of terminology, the oncotic pressure. You guys know that you are, wait a minute, what do you have next? You have midterm next. You guys know that you're Zooming midterm. Fabulous. If you want to go home and Zoom it, fine, aces by me. If you do not have time to go home to Zoom it, meet back in here, 5th period, and I will have you set up just like I did last week. Oh, and I forgot to mention, and I think somebody, I took the chat down. I think somebody went ahead and researched the dog show. I do have that on as a poll question on your Moodle. And you can go ahead and guess. I have that open only until tomorrow, so there's no cheaters where you watch the dog show and then make your vote. No. You can give best guess, and I can see everybody who voted and what you voted for, and everyone that gets it right, I'm going to throw you some extra points on the next test. So you don't lose out anything if you get it wrong. You don't lose out anything if you don't play. But it's like a lotto. You got a 1 in 7 chance of winning some points. So there you go. Oh, I'm ready to eat me some pecan pie.
Miss
Right,
Huff,
so finally, do what? I didn't get that, Zimmer.
I said I just emailed you.
Okay. So filtration. Filtration, I think of this very similar to a coffee maker. Okay, now I'm not talking about the fancy Keurig. I'm talking about good old-fashioned Mr. Coffee, where you put what? The coffee filter, scoop in the coffee, you pour in the water drips through the filter and pulls the coffee with it. That's filtration. We're literally pushing it through the filter via pressure. And the pressure is very, very important. If you think about your Mr. Coffee, how does it work if I forget to put water in it? Yeah, it's not going to work at all, am I? I'm not getting any filtration. What about if I try and fill it up with a fireman's hose? It's going to explode. That's the exact same thing as far as filtration in your body. You have to have the perfect amount of pressure to force our fluid and get our filtration. So that's our filtration, caused by pressure. And in our bodies, it's caused by our blood pressure and the strength that our heart is beating. That is our coffee maker. Oh, excuse me. Yeah, so this would be dependent on essentially like how hard is your heart beating. If your heart is like thud, 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 that would be like trying to fill up the coffee maker with a fireman's hose. But if your heart's just kind of like, now it doesn't have any water in it. So that's what I'm talking about as far as your pressure and your blood and your heartbeat. I just did some stuff on a heart condition last night for my own schoolwork. You guys haven't gotten into CV yet, have you? Cardiovascular? You guys are still doing bones?
Yes.
Fabulous. You tell me when you get to the heart, because oof, I've got stories. Oof. Tetralogy of Fallot. Ah, so good. It's a knee slapper, I'll tell you. All right, so those are our passive, 4 passive movements. Now we have some active movements. And these do require energy. I just spit on myself. These do require energy. I need that. I just touched my face. In the form of ATP. Why do we need energy to move them? Well, maybe they're not water, lipid soluble. Maybe they're water-based. Because we know that our cell membrane is a there you go. Just yell it out when you know it. Phospholipid bilayer. Waters don't pass through fats. So I might need energy to get something water soluble. Maybe the particle is too big and I'm gonna need energy, I'm gonna need something or else it's gonna rupture the cell membrane. And what happens to cells when that happens? They die. Maybe they're on the wrong side of the gradient. Remember that your concentration gradient is the difference between high and low. So imagine now, okay, so I'm moving with the gradient. The Texans game has just let out. We won. It was a victorious win, triumph. I'm moving with the gradient, moving with the crowd. It doesn't take me any energy at all until I go, oh no, I forgot my t-shirt that I bought for $387. Because you know that's how much they charge these days. At least seems like that. I forgot it in my seat. You ever done that? You ever tried to go against traffic? Takes some energy. So that's what I mean by the wrong side of the gradient. They're moving against the gradient. So because we have energy in the form of ATP, we don't have to worry about moving with the gradient. We can move with it, we can move against it. We have here symport, sim, together, moving with, antiport, anti, against. So this is just going as to what direction are we moving. What did you lose?
My ring.
Uh-oh.
It's right there. Oh. Okay.
Yeah, and stop everything. No, no. Heck no. I would have done the same thing.
That's really gonna come out.
Yeah, no, we got you. We got you. All right, so some of the ways that we can actively, with energy, move stuff. We have 2 different ways. We can move stuff into the cell, and we can move stuff, guess, out of the cell. Yep. I am determined to wake you guys up today. I don't know what I'm going to have to do. Hey, I have a question. What the heck are all the people doing with the toilet paper again right now?
It's happening again? Yeah. There's the rumors about going on lockdown, but I don't see it.
Okay, seriously, what the living holy heck is wrong with your digestive system that you used a lifetime supply of toilet paper in 4 months? Seriously, we went on lockdown in March. I have purchased toilet paper once since then. One time, and I still have probably a quarter of the package left. What the hell are these people doing with 5 and 6 big packets of toilet paper?
Fast metabolism.
I don't even want to know what kind of lava is coming out of that back end that they are using a lifetime supply of the toilet paper.
It's not just the toilet paper, though. We're out of paper towels, Lysol. the wipes, because I work at Target, we're out of everything and everybody's mad.
I went to Target last night to get a salad because I was craving a salad. So Target's my kind of go-to place. And there's no toilet paper or paper towels or even Kleenex. Now they've done a run on Kleenex.
I went to Sam's yesterday, and like all the toilet paper and all the napkins were gone.
Yeah. There was nothing. Now, my Target did have wipes. They did, because they're only allowing you to buy one. So mine did have wipes. And they have tons and tons of hand sanitizer. But I'm just like, seriously. What?
Amazon's already out.
They finally
What?
stocked up on the hand sanitizer, but this isn't even a digestive issue.
I know, thank you. I just don't understand what these people are doing with all the toilet paper. I thought one of you might have some sort of insight into the toilet paper.
I have no idea.
People are crazy. That's all I can say. People are
What?
What are you buying that's lasting you so long?
Why? Yeah.
What brand is it?
Oh, well, you also have to remember, I live by myself.
Oh.
It's only me at the house. And so I usually get what's the one with the bear? Charmin double roll.
You get like a giant pack?
I bought an 18
What
pack.
is lasting that long?
Yeah. 18 pack will use the double rolls. Will last me 5 months.
I mean, granted, you're home only like half of the time. So
I'm here, and every other weekend I'm at my significant other's house. So I use his toilet paper. But then every other weekend he's at my house and he uses mine, so it all works out. But I'm here 8 to 10 hours a day. So no, I don't go through very much.
Things like that just flies through everything.
Oh God, no. I don't go through toilet paper very often. Nope. Don't. Anyway, okay. Back to this. So we got endocytosis, taking stuff into a cell. Exocytosis, getting stuff out of a cell. We have a couple of different types of endo. Got a couple of different ways that we can get stuff into a cell. Phagocytosis, what does phago mean? To eat. Phagocytosis is taking in solid particles. Pinocytosis, what do you want to guess pino means? I don't have any wine drinkers.
Liquids.
Liquids, Pinot Grigio, Pinot Noir. Obviously, it's not spelled the same, but it helps me remember that Pinot is taking in liquids. So pinocytosis is bringing liquids into the cell. Receptor mediated is where it's a lock and key. I have something that may need to come into the cell, but it has to activate a special secret passageway before it can. And then exocytosis is where we remove stuff from the cell. It could be toxins, waste, things that we've made that we have to get out into the world. So exocytosis is the removal of stuff from the cell.
Can you repeat the receptor?
Yeah, so I've got a picture coming up. So for my little visual people, it is, I need to have a special key in order to activate and open it up and allow me in. Think of my car, my Jeep down there is a cell. And I'm trying to get into the cell. And you all want to get into the cell. How do I get into the cell but you don't get to? I have a key. And I can put it in the lock and I can activate and enter it. None of you have the ability to do that. That's what I mean by cell receptor. The lock on my door and the ignition will only activate with this. And then it will allow me into the cell. So our active movement, as I said, we do not have to depend on the gradient for this. We can go against the gradient, meaning going from low concentration to high. Moving against the crowd, trying to get back and get my t-shirt, which has probably been stolen by this. Yeah, of course it has. So endocytosis, if we're going to be engulfing solid material, it is phagio. So endocytosis is just the category. We're taking stuff into the cell. Phagocytosis tells me what is it? It's something solid. Pino, something liquid. Receptor, something specific. All three of these, though, are classified as endocytosis, bringing stuff into the cell. Do I have any questions about that? Is everyone okay? This is just basic terminology that we're going over. That's the only depth I want to go right now, is just the terminology. Pino is liquid. Cell receptor, as I said, there's a special locking key. We have a protein that binds to a receptor, opens it up. Just like the key of my car. I'll give you guys a minute. This is kind of a reviewy slide. Remember, Zoomers, if you have questions, please unmute yourselves or go ahead and write on the slide. That was really fun on Friday. I really enjoyed that. So if you guys are waiting while my in-live studio audience is taking notes, you're welcome to regale us with some lovely drawings. Or not, that's fine too. I'm excited for turkey. I am. It's just the two of us. Oh, heck yeah, we cook every year. Which is ridiculous because it really is just the two of us. But we do everything, the turkey and the stuffing and the green bean casserole and the hash brown casserole and mashed taters, rolls, and then I'm doing apple pie, pecan pie, and some other weird pie that he wants me to make. For two of us. Two of us.
Does it take a lot? Like, how long does it take for y'all to finish it?
Like we'll nosh on it for the rest of the weekend. Like the day after Thanksgiving, he makes turkey hash. Oh, change your life. Change your ever-loving life, that turkey hash. Oof. And then we'll usually make some soup, like turkey dumpling soup, all kinds of stuff. So by Sunday, we'll be down to the bones and throwing it away because we'll be so sick of turkey that we don't even want it anymore. Look at the dinosaur, you guys. Oh, okay, so I've got some question marks. Engulf. Engulf means, think Pac-Man. Okay, walk, a walk, a walk, a walk, a walk. And he's eating the little white dots, and he takes them into himself. That is to engulf, just kind of, and he brings it into himself. That's what engulf means. Here I've got a picture. Here I have phagocytosis. Get my laser pointer here. So here I have a particle, and it's going to come down to the cell membrane. The cell membrane is going to wrap around it, forming a vesicle or a vehicle, and pull it in. Pinocytosis, it's working the exact same way. The difference is that this is now liquid instead of solid. Here I have liquid, but I don't want liquid to get into this specific spot. Only the little stars can, and they come down and they bind with the receptor, and that's what causes a very special vehicle to take them exactly where they need to go.
Would that be like vaccines and stuff?
Not so much vaccines, because vaccines are immune response. This, I'm just bringing crap into the cell. And then exocytosis, and yes, I did Google image search dog taking a dump on someone's lawn. Because this is what I think of when I think exocytosis, is that the cell is now doing a poop. The cell the cell is ready to get rid of waste. It's not just waste though, because remember, our cells are making proteins, they're making all kinds of really great groovy stuff that need to be shared with the rest of our body world. And so here, it's the exact same premise, just in reverse. Instead of having something coming down, binding, and then releasing it here into the cell, I have something binds with our cell membrane and releases it to the outside.
Class is almost over. Who did? In the middle.
What, Zimmer? Do you have a question?
Negatives. I had -5 though. That's not much. I'm gonna box all the.
I don't know what that is about. All right, is everybody okay with the movement of stuff in and out of the cell? Everybody's cool? Now I want to talk to you a little bit about cell division, cell replication. This is exciting. And I know some of you are like, oh my God, I'm having PTSD from the old biology class I used to be in. Don't worry, I got you. Cells have to multiply. That's really kind of a no-duh. There are two ways that cells can multiply. We can either get a cell replicating and forming an exact copy, or we can have a cell replicate, multiply, and not have an exact copy. When we are looking at reproduction, we are getting a contribution from one cell, the egg, and a contribution from another cell, the sperm. Bippity boppity boo. We're going to mix it up in a stew. Bam, there you are. You are a product of meiosis. Meiosis is where we have multiple cells contributing, and the cellular offspring is not identical. It can't be, because you got a little bit from your mom and a little bit from your dad. They got a little bit from their parents, and so on and so forth from the dawn of time. That's not what we're discussing here. What I am interested in is when we have a cell and we need that cell to bloop out an exact replica. The new cell has DNA that is an exact match for the cell it came from. It already has the blueprints. It knows the job it's supposed to do. It knows how to do the job. It knows how to interact with other cells. That's mitosis. And I think last week we were discussing a little bit about how radiation can affect this. Radiation can come in and kind of start mixing stuff up. So now when I am replicating that cell, I'm now replicating a cell that is incorrect to begin with. Big problem. So we are going to be focusing on mitosis for this chapter. We'll be getting into a little bit of meiosis when we do the reproductive chapter at the end of next term. All right, so all cells have a life cycle. Okay, you have a baby, you go to a toddler, teenager, adult, senior, death. Just like people, I anthropomorphize these cells. We basically have two distinct times in a cell's life. We have the time that they are dividing, and we have the time that they are not dividing. That's it. We split it up into these two things. Are they dividing? Are they not dividing? Now, the cells are actually going to spend the majority of their life not dividing. They're going to spend the majority of their life preparing to divide. Because if you think about it, although the division part, pretty cool, pretty amazing, think about all the preparation that we have to make before we can do that. I am a cell. First thing I got to do, replicate my DNA, because my new cell is going to need it. So I am going to have to make an exact copy of my DNA. Next thing I'm going to have to do is make myself bigger. If I'm trying to get 2 of me out of me has to be double the size, doesn't it? And don't I have some organs that are helping me survive? Doesn't my little daughter cell need those same organs? All of that has to take place before we divide into a new cell. All of that is going to be happening during interphase. Interphase is the preparation. The cell is getting ready and just going about his daily chores, right? I have a liver cell. He's just doing his little liver cell job. He's, maybe preparing to divide depending on how many burgers I had. He's getting ready, but otherwise he's just doing his little liver job until he can no longer do it anymore, and he creates somebody to take over his spot. So interphase is classified as simply the period of time between active divisions. Remember, we've only got 2 times in a cell's life. Are they dividing or are they not dividing? This is not dividing. Back when I was in college, we called it the resting phase. That was a million years ago. We now know that's not the truth because cells never rest, hopefully. If your cells start to rest, you're in really big trouble because then they're not working. So what we now call it is the metabolic phase. Metabolic simply means we're going about our daily lives. We're doing our job to the best of our abilities. Metabolic phase, interphase, again, just means not dividing. We're going to have a nucleus. We're going to have our visible chromatin. The cell is just going about doing cell stuff. Does that make sense to everybody so far? Is everybody on the bus so far? Because I know you guys were a little nervous about mitosis. The most complicated thing about mitosis is when we start replicating our DNA. We got a couple of terms that we're going to go over, like some of you who have taken, I'm assuming everyone in here has at least a rudimentary knowledge of mitosis. You've heard the word before.
I never had biology or anything like that in school.
Fabulous. So I know who I'm teaching to. No, to the person who doesn't have any experience. Are we good so far?
Yeah.
You're going to be my gauge. All right, so here's what the first thing I got to do when I'm getting ready to split and create a new cell. I got to replicate my DNA, and this is a whole process. Holy smokes. I've got this double helix strand of DNA, and the first thing I need to do is unzip it. So now I have 2 single strands of DNA. Can I take this single strand and turn it into a complete DNA? Do we have the capability to know how to do that? Of course, well, yeah, the actual answer is yes. Yes, we do. Let me explain. I have my DNA. Let me get my pen here. So I have my DNA. double helix. I'm going to unzip it. Bzzzt. So now I have 2 single strands of DNA. I can take this one strand. I'm going to take just one strand and I'm going to set him right here. I have nucleotides. Looks like half of a ladder. And I'm going to now fill in the letter for these nucleotides. I'm just pulling these out of my head. We have guanine, cytosine, thymine, and what's the fourth one? Adenine, yes. So if I have half of these, can I create a whole DNA? Sure I can, because I know what has to bind here. G, C, C, A, T, T, G, C. How did you know that? Apple tree, put your car in the garage. I now have a perfect copy. And this strand here is exactly the same, except it was starting out with this. That's a whole lot of stuff to do. In order to unzip my DNA. As I am unzipping my DNA and I have these 2 strands and I'm reassembling the DNA, one of them is a lot smoother than the other. So my one DNA is gonna, here's my, oops. Thought I had my pen going here. My one DNA is going to unzip. And as it's unzipping, I am just filling it in. Actually, I am filling it in this way as it unzips. We unzip, immediately fill it in, unzip, immediately fill it in, so on and so forth. Nice and smooth. I'm just filling it in as it's unzipping. I, however, have another strand of DNA that I have to fill it in the opposite way. So what's happening is, let me go over here. So I've filled all of this in, and then I got to go back here to this part that's unzipped. And I fill that part in, and I got to go back here to where it's unzipped. Do y'all see how kind of jerky? It's unzipping from here, but I'm filling it in this way. So by time I have filled this in, I now have a whole blank spot. And I have to go back and fill it in. And then I got a blank spot. I have to go back and fill it in. Is everybody with me on that? This strand that is a continuous strand is known as the lead. This strand, super jerky. What do we call our computer when it starts to stutter and get super jerky? It lags. So we've got our leading strand and our lagging strand. That's a lot of words right there. I don't want you to panic. I've got some players in this whole story. When we're going to replicate DNA, the first thing we need to do is have somebody to unzip it. That guy's name is helicase. Then I need to have somebody that comes along and matches the nucleotides, pulling out and matching them up, pulling them out, matching them up. The guy that's responsible for that is known as a polymerase. I think of it because a polymer reminds me of like something that is sticking. If you have a polymer like Polygrip, sticking it, so our polymer is grabbing them and sticking them together. We have our lead strand, which is a continuous, and our lag strand that has to continually go back and fill in the blanks as the DNA is unzipping. I have a little video that I'm going to show you, and I will attach it to my website. Now, it's very elementary. It's adorable, but it's a little cartoon. It's very elementary. It's put out by, I think they're fabulous, for just a very basic explanation of stuff. This is called the Amoeba Sisters, and they're wonderful. So what I want to do is I want to show you guys this little quick video. I will link it to my Moodle. It is on my website.